Okay, so I'm going to attempt off the top of my head with apparently no prep to try to derive the law of cosines. So take yourself a triangle, right? And you label it with angles A, B, and C, and sides, little a, which is across from angle A, little b, which is across from angle B, and little c, which is across from angle C. And then you want to somehow make yourself the law of cosines out of this thing. Okay? So to my recollection, I should be looking for the Pythagorean theorem in here somewhere. You guys cool with that? Why can I not straight up apply the Pythagorean theorem to this thing as it says? Good, because it's not a right triangle, probably. If you pull a triangle out of the air, it's not right. Thanks. Okay, so what I'm going to do is make it a right triangle by cutting someplace here. Cool? So I'm going to cut like this. So I don't know that I cut angle C in half, right?
We got C sub 1 and C sub 2.
Okay, see that? Yeah, and really, actually, those angles are not so bad. What's this angle here?
That's somewhat
C1 minus C. On the left side is C1, on the right side is C2, and it would be C minus C2.
Okay. Or you could do this. It's 90 minus A.
Yawn.
You guys see that?
Yeah, I mean, it makes way more sense.
And then this angle here is
90 minus C minus C.
90 minus B. Right? Okay, and I guess maybe I'll split this into little c1 and little c2, I guess. I don't know. Okay, so what do I know here? I know that little c is little c1 plus little c2, right?
Yeah, man.
Totes? Okay, cool. Let's see.
Can we name that line you're dividing C with? Name it H. The height.
Oh, okay. You want to call that h for height? Okay, cool. So what else do I know then?
You know that H squared plus A squared equals C sub 2 squared.
Okay, so if I take this triangle, right, and apply the Pythagorean theorem, right, I'll get b squared is h squared plus c1 squared.
And then the same for the other triangle, but instead of, you could say.
Okay, so this would tell me that a squared is h squared plus c2 squared. Okay, cool, good. Next, thoughts?
Could you, C squared both sides, you can have H is equal to both of those.
Okay, so we could do that. That's not a bad idea. So
Get H alone on both of those and then set them equal to each other.
yeah, so I can isolate h squared here, right? So h squared is b squared minus c1 squared. And over here, I get h squared is a squared minus c2 squared.
Yeah.
That seems like a good idea.
So that means those two are equal.
Okay, so that's going to tell me that b squared minus c1 squared is a squared minus c2 squared.
What is that, the commutative property or something? No, that's.
Transitive property? That's really its translation, right? It's if this thing is h squared and this thing is also h squared, then this thing must be that thing. Okay, so I got to here. Great. Now what?
We should get cosine involved somehow.
Yeah, I should probably try to get a cosine in there somehow. That seems like a good thing, right?
Yeah, maybe.
Okay, so
Let's do angle A, shall we?
okay, so let's try for angle A. So from angle A, what's the cosine of angle A?
You got C sub 1 over B?
Okay, so that's this triangle again. So I'm thinking cosine of A is
C sub 1 over B.
C sub 1 over B.
Mm-hmm.
Okay.
Cosine of B, which is C2 over A.
Okay, and here I got cosine, oh wait, I don't want cosine of two angles though. You guys see
You
this?
just said that they're equal, so. you
I
probably
think
need
I
to-
really just want one.
Okay.
You guys see that?
Mhm.
Best I can figure. We can write it down anyway, but my guess is I don't want that. So cosine of B is C2 over A.
Let's just focus on the group one.
Okay, so I got this, right? This is C1 is B cosine of A, right?
Yeah.
Okay, so I could put that in for C1 over there,
Yeah.
right? So I could get B squared minus B cosine A all squared is A squared minus C2 squared.
Yeah, man.
Cool. We're getting somewhere, probably, maybe.
We know C squared is, on one side of the equal sign for, cosine. So maybe we should try to do that.
Oh, okay. Yeah, we could try to put things.
How did you replace the B cosine A with C1 squared?
So we said that cosine of A, right, should be the adjacent side of A divided by the hypotenuse. So in a right triangle here, right, that's C1 over B.
Yeah.
And then I multiplied both sides by B to get C1 by itself.
Oh, okay.
So I found out that C1 is B cosine A. And then I put that in over there for some place where I had a C1.
Makes sense, okay.
Okay. So, let's see. I need to get rid of that C2 somehow,
Can we
right?
do the same thing?
How can I get rid of C2? What's C2?
It's
C minus C1.
not half,
Yeah, it's C minus C1, right? You guys see that? And I know what C1 is. It's B cosine A.
but yeah.
Yeah.
You guys see that? Okay, so I'm going to put that in for C2 here. So I got B squared minus B cosine A all squared is A squared minus, and here I need
C,
C minus C1.
Yeah.
yeah, and then you can.
Okay, but C1 was
B cosine
B cosine A,
A. Well,
and then I need to square this thing, right? You guys all see that? Okay. So this thing clearly needs to be pointed more in that direction. Okay, now what?
Why'd you need to square the second one?
Why did I need to square the second one?
C2 is.
Yeah, C2 is squared.
Okay.
So I need, this is C2 apparently, and I squared it. Okay, so let me FOIL, I guess, a little bit.
Sure, why not?
Okay, so over here I got a B2 squared minus, sorry, B squared minus B squared cosine squared A. You guys all with me on that? And on the other side, I have an A squared minus,
C squared
Well, yeah.
good, there's a C squared,
Minus,
B
or
squared.
plus 2A, or 2B cosine A.
plus 2CB cosine A. Good. No?
Oh, yeah, because there's another C, there's another.
Okay, so I'm foiling this thing, right? So this is C squared minus 2CB cosine A plus B squared cosine squared A. Right? Foiling. And then I'm flipping all the signs. So I got minus this stuff. So I got minus C squared plus 2CB cosine A. And then I need a minus B squared cosine squared A. Oh! Huh. Great.
What?
Cool.
You guys see what I'm saying?
Yeah. 'Cause I cancel.
Yeah, because there's a b squared cosine squared a over here, and there's a b squared cosine squared a over there, and they have the same sign, so I can cross them. Because that's me adding b squared cosine squared a to both sides. And I'm psyched because the law of cosines doesn't have a cosine squared in it. So I was wondering how I was going to get rid of that.
There it is.
You guys see that? Okay, so all told here, what I have is I have b squared equals a squared minus c squared plus 2cb cosine a.
Oh, it's teasing us.
Yeah, so...
Add c to both sides and subtract b squared.
The A has to.
Yeah, so A, right, is the side opposite the angle that I ended up taking cosine of.
Oh, okay.
You guys see that? I cut my triangle differently than I usually do.
Yeah.
You guys see that? So I'm going to end up with the letters in different spots. But I should end up with something that looks like the Pythagorean theorem minus some kind of compensating factor, right? So if we rearrange that a little bit, by what? I need to subtract,
A squared.
I think I want to add c squared and subtract 2cb cosine a. So that way I'll get a squared equals b squared plus c squared minus 2cb cosine a.
Woo! You did it.
Which is the Pythagorean theorem and a little compensating factor, and of course rearranged from the way I usually write this down.
Right. If you add c squared, shouldn't be c squared be on the outside equation?
That's only.
Oh, I added c squared and then reversed the order. So if you add c squared, right, and subtract 2ab cosine, or 2cb
Oh, you just took both those things, put them on the other side.
cosine a, and do the same thing over here.
I get it.
Then this junk cancels, and that stuff, and then I switch the order because I don't know.
Okay.
Cool.
You.
Cool. So what's the moral of the story for next time you do this?
We're just
Don't do
memorizing.
that.
Cut it the right way. Don't cut it the wrong way. Cut one of the other angles because you want that C, right? So that's the one you shouldn't cut in half. Well, not in half, but in parts. Cool? Question?